welcome to new norm talk. So I first prepared this talk for the conference here in New York, PGConf New York, and which was supposed to start on March 21st, 2020, which did not happen. And so this presentation never went to live conference, and then I did it twice virtually on 2 conferences, so it was pre-recorded talk. And so now, when it was first live conference since then, I was like, you know what, I like this talk, I want to give it live. So it's somewhat outdated because it was like, prepared almost 2 years ago, so some numbers are different now probably, but the ideas, I think the ideas are still fresh, and most frustrating, probably they are way too fresh. So I'm trying to popularize this approach, and I get, not like I get very little traction, everybody say it's super cool, but then like very few companies actually adopt this approach. So today is my second day with Enterprise DB. So I hope that as part of this move, I will be able to facilitate adoption of these ideas in different parts of Postgres world. So, new norm. What is norm? Norm is no ORM framework. And for many years, people talked about this your JSON thing. So I tired of being this JSON thing, and we came up with this abbreviation, norm, and I think it's actually very good because I think this normal approach. So what this talk is about, this talk is not about Postgres, actually. Pretty much, yeah. And so why I'm doing this talk, like already multiple times on the Postgres conferences. This talk is about, because we're talking about ORM, this talk is about interaction between application and database, how this interaction can be done in most efficient way. And why we care about this. So I think this underdeveloped area, and that's why, again, I'm trying to talk about this problem. So why we care about how application and database interact. It's all tied to performance. Because again, nobody, I mean, okay, somebody queries database directly, but our end users do not query database directly. They do not write SQL. They query database through the application, which runs on the web, and queries database from the application. And response time matters. Time is money more than ever these days. And it's not like even theoretically, not as a figure of speech, but very practically. Again, these numbers are kind of pretty old, but I grant you they did not become better. If something, they became worse. So Amazon reported a while ago, 1 second page load slowdown results in 1.6 billion lost sales per year. And Google reported that showing search results by 0.4 seconds is loss equivalent to the loss of 8 million searches per day. So slowness actually have very material outcome for any companies who do business on the internet. And the worst part is not that even. The worst part is that half of the visitors abandon website which is not loaded within 3 seconds. And for this, I bet that now it's not 3 seconds, it's like something like 1.6, 1.7 seconds, because people become more and more impatient. I still remember the times when 10 seconds was good enough. So no, forget about it. Then it was 6 seconds, then it was 3 seconds. I think now it's 1.6. And what is even more alarming, 79% of visitors never come back if they once experience the slowdown. So we need to take care about this, and we need to see what slows things down. Actually, if you think that it is slow because Postgres is not fast enough, or we do not have right indices, or something like this, actually, sad story, most of the applications slow down is not because something is wrong with Postgres. This is the application developers think, right? Something does not work, Postgres sucks, right? No. Postgres is fine. So what is our worst enemy? So that's what we see. We expect application to respond fast, and instead we have this wait, 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 wait. So what is this cause? What is the source of this worldwide wait? ORM? So I'm sure that anybody who ever contacted application developers know what is ORM. ORM is an object-relational mapper, and that is a program, a software, which is designed to bridge the gap between database and application. So application developers do not know SQL. They think they know, but they don't. And they do not like to get into database. They do not want to understand how database is organized. So they want a tool which helps them to map their application objects to the database objects. And this ORM, it actually does a great job just filling this gap. It solves the problem of abstraction of details of data storage to the application, but what it does not solve the problem that application does not know how to manipulate with data sets. So the same old impedance mismatch, which was on the picture in 1980s, now it's called object-relational impedance mismatch, but it's the same story. Application does not know how to operate with data sets. So we have application, and application has its own data model, and we have database model. And here we have object-oriented model, and on the database side, we have object-relational data model because Postgres is object-relational system. And these models know nothing about each other. They are like galaxies, which are like many billion of years away, and they do not know, they cannot talk. So how they talk? You think they talk just bringing data from database to application? No. So actually on the way, like for example, here example of Java application. So JDBC can only transfer simple scalar types and can only transfer simple flat tables. So application transfers its data to flat tables, and then they are moved through JDBC to database, and then we do like, instead of querying like, instead of running real query, we do like select star from table A, select star from table B, etc. And here is ORM. So ORM does this transfer, transferring application data to these flat tables. And then that's what becomes bottleneck. All the small queries, because that is going back and forth, and that's where the real slowdown happens. So then, yep, just this data cannot go through JDBC. So what was the solution that, so this solution was developed in Previan Holdings, that's like previous my place where I worked, and that's how norm solution should, looks like. So instead of trying to map application to database or trying to map database to application, we developed transfer model, which is JSON, because you know what, let's be honest, these days, they're only JSONs. Like application operate with JSONs and nobody knows nothing about JSON. So we developed this intermediate model and we map application model to JSON, and we map database model to JSON. And then we establish this contract, and then so we never disassemble the complex objects, these complex models. We transfer the whole objects between application and databases. So here is how we do this. So we convert, the other thing, JDBC does not understand JSON, by the way. So in order to actually transfer data, you need to convert JSON to the set of strings which are actually grammatically correct JSONs. So then we transfer this text, and then these objects are like picked up on each side and processed by each of the side, application and database. So, you know, application developers like contracts. So we have contracts on the application side, and so to make life for application developers easier, we introduce contract between application and database. And our contract is this JSON structure. So we define exactly what is JSON application wants to see. And then we guarantee that when the talk to the database return to them exactly this JSON of this structure. And this way they actually can abstract from how we store data, because all they need to know what they receive. And we guarantee that they receive exactly what they want. The example goes, that's a very simple database schema. It's account. So all applications have accounts, right? All applications has users, and user has accounts. So account will be like username, last name, first name, date of birth. Each user might have multiple emails, and each user might have multiple phones. It may be primary, secondary email. There may be like phone might have different type. I think now everybody has cell phones only, but for some reason we still keep having work phone, like house phone, even like before pandemic. Like who really? I don't know. I don't know how many people actually has like work phone, but anyway, we have phone types and we have phone priorities and we have email priorities. So very simple database schema, but that's very close to what we have in real applications in real life. Now we map it to this mapping transfer layer object. So what is this object? We have account record, and we have, for each account, we have multiple phones which are part of this account, and we have multiple emails which are also part of this account. And how it looks as JSON, that's how it looks. So this is absolutely grammatically correct JSON, which represents exactly what we need. We have like main JSON, and we have two arrays of JSON inside. Each of them may be empty, may have one element, may have multiple elements. So that is how our contract between application and database looks. Now, how we built it. Because now finally, okay, like what it is, like, okay, 10 minutes through presentation, we're finally getting to Postgres a little bit. So how we're doing it in Postgres. User-defined types. So lots of things I love about Postgres, like everybody here. So one of the things is user-defined types. You can have user-defined types, and user-defined types can be nested. So we can, what we do here, we create phone type, we have email type, and then we create account type. And account type contains two elements which are arrays of records of the other types. That's that easy. Yeah, that's what I'm asked all the time. So by that point, if not earlier, people are asked, okay, why you are doing this? Why you are going into these complexities? Postgres has perfect JSON support. Why you want to store JSON? So why you do not want to store JSON? So one thing is the power of relational search. So yes, we have indices which allow us to search in JSON, and yes, when we do not have a lot of data, it works fine. But if you ever tried, and I actually have experiments, so I have this data, if you compare how fast the search in JSON run versus the search in database, in relational tables, for online application with like lots of data, and with like when we need fast response time, it actually matters, so it's a big difference. The other thing is we do not want to lock the hierarchy. So here, when we have accounts and phones, it's pretty much one hierarchy. But you know, examples I showed actually in other presentations, the airlines database, for example, okay, so from a person perspective, they have airline ticket and they have like multiple airline tickets on different flights. From the flight manifest perspective, you have a flight and you have multiple passengers on this flight, like as easy as that. So in the real world, we do not want to be locked in one hierarchy, because otherwise we are back to hierarchical databases from the 1970s, right? Or like early 80s. So that's like the other thing. And the other thing people often ask when we'll get to the next part, how we return it, why you do not return JSON. So if you want to give application JSON, why you are building these complex types? So you can build JSON right away. So that is the thing that we want to have strong types. So what we want to always satisfy the contract. So we want to make sure that there are checks that when we return something, we return exactly the type which application wants. And again, I will show how we guarantee this in a little bit. But JSON does not have type. JSON is JSON. So there is no way to check that JSON has exactly the structure which we agreed upon with the application. And when we build JSON from nested user-defined types, that's what gives us this option to verify that we are returning exactly what we promised. So that's how it looks like. And I will show this code a little bit later as a part of the function which returns JSON. But I just wanted to show this select separately, how we build JSON, not JSON, but how we build complex type. So we build complex type. We do the subselects. For each of the subselects, we convert results to the specific type, and then we embed it into one select. So here we select everything for this user account, and the user account ID is like predefined somewhere in the function. Good news, all these examples are available online in GitHub, so you can like run it, you can look at it in more details, and etc. So like, do not think that you will miss out if you did not read like the whole thing from. Then last portion is converting to text. Or actually, for Java, you need to convert it to text. For others, you need to do not need to convert to text, but you still need to convert it to JSON. Because if you try to return nested type, I will show you when I will run the demo what it returns. It returns something ugly. So in order to be able to return something which is readable, you need to convert it to the JSON. So here is one important thing, because when we started this project, we thought that we can convert to JSON while selecting. Building JSON while selecting is slow. When we already have the result set built, converting the whole thing with JSON, it's one transformation and it's very fast. So this way we are not losing anything on building JSONs. It's a super simple function, but it's kind of like the key to success, because this allows us to produce the output which can be consumed by the application. Now, how we built it. Again, this example is on GitHub. I presented this for a very long time without giving example, and people like, show us how to do that, not on what you are doing in your company, but show. So we built this example. It's like pretty well organized, and again, you can get there, you can download this data, build your test database, and run everything. So, it is first thing we do have here, like each good GitHub, we have load all, and this load all, okay, this animation should work hopefully. So load all has this everything which we need to build. So first thing we are building the tables. So first we do create tables. All right, I cannot make it faster. Okay, yeah, so we do create tables. And what we have here, we create all these tables from the database schema, have phones, emails, accounts, and everything. So we are done with this. Then next thing, we are doing array transport. So we're creating this array transport function, which converts everything to JSON represented as strings. So then next thing we do initial data load. So we insert 4 different accounts, then we insert phones, and we insert emails. And after that, we are pretty much ready, I believe. Okay, does it stop? Okay, when does it stop? Okay, nope. Something else? Nope, that's, all right. Yep, okay. Yeah, so that's what we do. Okay, so then next thing, we are building package. So I come from Oracle, from very, very long-term relationship with Oracle, and Oracle has packages. And Postgres still does not have packages, which I think is big deficiency. Now, at least we have stored procedures, but we don't have packages. And I think packages is a very important concept for interacting with application. So I am emulating packages, which is I have definitions of types together with functions, which we use to manipulate these types, with these types. So here I am building this account package. So what we have? First, we define all these user-defined types, which I described, okay? So we define this one, and then we have functions. So first function is account create. So that's how we interact with application based on JSON. So application send us JSON, and this JSON has complex structure. And what I'm doing, I'm parsing this JSON here. And while parsing, I can tell, okay, some of these keys belong to account. Some of them belong to phone. Some of them belong to email. So we insert email, and after we insert email, we have, not email, account. After we have account, we have account ID. Then we parse each of them. We parse email and we parse phone. And when we parse them, we insert and we create matching records for as many phones and emails which were passed, maybe none, then we do not create them. And at the very end, what we are doing, we are returning this account. So we call this function, which is select account by ID, or we have actually search by ID. So here we have search by ID, and this function does this SQL, which I showed separately, and it returns the array of types. And after that, we apply array transport. So the reason why we need at least one function to return the type, because we want to ensure the strong type dependency. Because otherwise, we can change something and we would not know, and as Magnus described, function would not know, and everything will collapse. So this way, when we drop the type, then the type would drop cascade depending objects, including the functions. So this way, when we have it in one file, it kind of like forces us to have consistency between how we define types and what we are selecting and what we are inserting. Now, we want to search something more interesting than searching by ID. Everybody can search by ID, right? So, one more technique, account search. We have search JSON here. So we have search, again, application does not know anything except for JSONs. So application sends us set of search criteria which are organized as JSON. And search criteria may be also something from account, something from phone, something from email. And here we parse the search JSON, and we build the search criteria. So watch closely here. We build search criteria to select account IDs, because we cannot put conditions on emails and phones, because then we will reduce our result set. So we want to collect all the account IDs which satisfy all search criteria which we have. And then at the end, we unionize all of them, and we not unionize, we intersect all of them. And then we write dynamic SQL, which returns all user accounts which satisfy all these criteria. So here it's always end, but again, in majority of applications, the criteria means end, because what users do on the other side, they select something from drop-down list, or they do like type ahead. So here, actually, we can do search by beginning of anything. So we use like text pattern indexes here to support the search, and we built complex criteria of any kind. Okay? And that's another good feature here is the power of dynamic SQL. Now, we not only search, we also want to update. That's also people ask, okay, you can do this, how you do update? Same story. So something is updated in the application side, and application send to us JSON to update. And what we're doing here, we are now parsing JSON for update, and we're trying to figure out what exactly we're updating. And mind you, update is not only update. We also might insert new phone, or insert new email, or delete phone, or delete email. So everything is more or less kind of like understandable here, because we check whether we have ID. If we have ID, it's update. If we do not have ID, it's insert. It's something new. And if we have delete, okay, we have delete here, yeah. And so if we have delete, we had to actually introduce the separate key, which is called command, and this command allows only one value, which is delete. In this way, we can delete phone or delete email. Okay. Otherwise, like as I said, we do either insert or update. So here we can actually update like phone which already existed, or like insert which is not. All right, so again, everything is available, everything is, yeah, here comes this delete, yeah. So if, yeah, that's, we did phones, then we do update, insert, deletes, update, insert, delete emails, and yeah. Pretty much same as insert. Yeah. Right. And at the end, when we're done with updates, we save one more round trip because we return the updated object. All right. So now, examples which are pre-recorded. So first of all, let's make sure that we know what we have. So after we have the taste data, we know that we have 4 accounts, 3 accounts, sorry. 3 accounts, we have 2 phones, and we have 2 emails, right? What we have? I have 2 emails, yeah. Okay. So now, we are done with that. So let's insert. Okay. So now we are creating new account. We create new account and pass JSON. And we can see that it returns a nice, beautiful JSON. So we inserted account all at once, all details. Next thing, we are, here is the difference between search and select. So when we do not convert to JSON, that's what we get. If you try to return complex type, that's what you will get. Like this ugly structure, which nobody will understand, starting from application. And if we apply array transport, then it actually returns what we need. Understandable JSON. Okay. Right. So now let's select, so there'll be several selects using different complex criteria. So here we search by last name and by username. And in both cases, it's by like operator. So here we need to have last name like John and username like Ellie. Okay, so we found actually 2 ones here. We found 2 ones for the last name like Johnson. Okay. Then the last one, or the next one, we will select only one of them. Okay, why we're not doing it? Okay, here we're doing it. Okay. All right. So here, okay, so here is nothing because there is no user with this last name and with this username. Okay. So then, what we have? No, this is the same one. Okay, that's wrong because that's the same one. It should do the same. Yeah. Okay. All right. Now, so next one we search by username and by phone, and again it's the beginning of the phone. So we got 1 record. And next we search just by phone. All right. And next one. Again, last name and email. All right. So now let's do update. First one is easy update. We have existing account and we change username. Okay. So we run update and we see that username changed. Okay. All the rest remains the same. Now we are trying to update phone, and here we pass phone ID, but this phone ID does not exist. So although we issued update, it will actually change nothing because we are changing non-existing phone. Okay. So it will return the same record and nothing got updated. Okay. There's like, because phone ID here was free. Now, for next one, we are doing update. Okay, so here nothing changed. Now here we are passing phone and we are not passing phone ID. So what we are saying, we want to insert phone. So no matter how many phones this account had, we want to insert the phone with like new value for the phone. So same thing, but ID is not passed. Okay? So now we actually added the phone for the same account. Okay? So count the same, previous phone remains and new phone is added. Now we are saying delete the phone with phone ID 2. And whatever else we pass, it will be ignored. So the count. Phone. And is it? OK, super. Delete it. Okay. And the last one, what we're updating here, we are inserting email address. Because this account did not have email, so let's insert email address for this account. Right. Now this account has email. Awesome. All right. And I have here. That's it, right? Yes. I think that's it. All right. So additional consideration. So this part of this presentation was done like for Java. Since then, I actually implemented the same thing for Ruby on Rails and for Active Record. That's way more difficult, you know why? Because Active Record thinks it knows better than anybody, and Active Record, gosh, yes, no, that's such a resistance. So that was super challenging. So one thing actually turned out that good news, I do not need to convert it to text. So Active Record actually can process JSONs, so like one thing less. But the other thing that we actually needed to teach Active Record to read database catalog for record types, which is possible because, I mean, record types are in catalog. So after all, we taught Active Record to do the same thing, to read data types instead of tables and take all the values from there. So it all worked well. It like requires some additional work on Active Record side, but it's done. Okay, so that's like one kind of area. So I know that it works in different environments, not only in Java. Again, lots of things about JSON, so I'm repeating it again and again because often, when even at this conference and other conferences, you hear the talks like, okay, we need to compete with NoSQL. Who said we need to compete with NoSQL? For some reason, we need to compete with NoSQL. No, we don't need to compete with NoSQL because we do not have to store JSON to give application developers all these advantages of dealing with JSON. It's way more efficient. It makes way more sense to build JSON when we deliver results to the application. So that's like a thing I'm just keeping advocating for. If they want JSON from us, it does not mean that we, as Postgres, have to store JSON, because we want to have this flexibility. Here, as you could see, we can actually change the database schema how we need it, depending on what our needs are, what makes more sense, how situation changes, how data is growing, whatever. So the only thing we need to keep our contract with application. As long as we return JSON of the agreed structure, nobody suffers, and we are in business. All right, so that is short version. I think I'm doing this talk last time because it had been it had been presented multiple times, so hopefully, now my hope is that I'm closer to, where Postgres is made. I can, kind of build it in Postgres, because all this what I showed, on one hand, it's simple. On the other hand, okay, we need, what do you mean? You mean we need DBA for, we need DBA database developer for everything? We do not want to have database person in our team. We are like small startup. We do not want to have database person. We do not have budget for database person. So my new kind of direction of work on this, many of these packages can be generated or semi-generated very easily. And what we need to do, actually, we need to develop a generation of these packages from JSON schemas. Because we have JSON schema, we feed it, and application also understands JSON schema, and most of it can be done automatically without DB person. I mean, some things always need to be fine-tuned. Complex searches always need to be fine-tuned, because this is something which no artificial intelligence can do, some complicated cases of database performance. But other than that, I think that's the path to go. All right. So, any questions? Yes? Uh-huh. Sorry, JSON-based what? You effectively created a JSON-based API. Yes. Yes. Mm-hmm. Was the requirement for the use case that led to this, that the application would always be directly to the database? Why didn't you consider putting a service layer in between? The application is also a service. The service represents or abstracts the logic for service. So what the service, I mean, this does not require anything. So the thing is, we are taking out anything and it's just talking directly. It saves time. So again, remember the very beginning of this presentation, the goal is not to show how cool is Postgres. I mean, Postgres is cool, but the goal is to make it performant. So we actually took Hibernate out of it. I can tell, specifically name the evil. We took Hibernate out of it. And our application services talk directly to database. It just saves on round trip, saves on everything. So Hibernate goes back and forth. So about Hibernate, actually, I can talk a little bit more, because Hibernate is one of the very good ORMs, and technically speaking, it allows to build in direct SQL. But that again requires somebody knowing that there's a place to write direct SQL, and when you have an option not to think about this. So the thing is, application developers have lots of other things to worry about. They do not need to worry about how to write efficient SQL. They have all other things they care. So when they develop, they kind of want to reuse the things. And what I kind of realized, because I've been doing it even for Oracle, long time ago. But when you give this tool, So they are done. You know, they do not need to worry about this, and then they do not even want to do anything else with it. They give us what they want to receive, and they receive exactly what they want. Because in any other case, you know, especially when they start to modify something, it's adding one more thing, adding one more thing. The worst examples I saw with active record communicating to Postgres, there were like several hundred database calls per screen rendering. Because when developers develop application, and when they need to modify, they are not going and are not looking, oh, whether our query efficient. They add one more object, or they modify something in existing objects, and that like adds and adds calls. Even if the original one is efficient, it's like I'm not over-exaggerating. Like I observed up to 1,000 calls. Because even like user account, that's a super simplified version. But if you think like, for example, okay, you log into your credit card, right? So what you see, and that's what application does on the background, your personal information, your like list of statements, and like your like last payments, etc. And each of these is several distinct database calls. You know? So when we say to them, okay, we are taking care of this, like don't worry. And then when they need to change something, they come with us to this, with this contract change. So now we need to display this and that. They're not like messing up with this. And then we take it, okay, so what we need to do, what other pieces of data we need to display, and how we will do it efficiently. And I've been modifying it multiple times because, so again, dynamic SQL with Postgres is also a super awesome thing because the functions, if we are not building them dynamically, the query is not optimized based on like the specific values. So when we build it and we execute the query which was just built, then we actually achieve optimal performance. So that's a super powerful tool. And I had situations when I needed to change it several times because it was performing, then it stopped performing. Why stop performing? Or, you know, but here, it like optimizer stopped doing the right thing because something changed with the data. So then, okay, how we modify the query so that we tell optimizer what to do. And sometimes we had them to break it to have several dynamic queries, which is absolutely counterintuitive, but, you know, yeah. So that gives us powers to give the best of Postgres to our users. Okay, thank you.